special effects studios that are at least within range of what we have here in Hollywood. And there aren't any over there. So
and not only that, Bill, I mean, we're talking 10 years ago.
Right.
We're talking 1975 and 76 when he gathered most of the hard evidence. And, you know, a lot has happened since 1975 and 76. Today we can look at the shuttle, for example. We know that they're creating metals in space and crystals. So that's no biggie. But in 1975 it was. I mean, a cold fusion process for metal. Come on. And this is what blew the scientists away.
It was a cold-rolled way of making an alloy.
Mm-hmm.
We don't know how or why we should do anything like that.
That's right.
There's some question about whether there was calcium in it or not.
There were traces. There was also thulium. And this, I think, really disturbed Vogel more than anything else. I just finished editing our next tape, and it's called Beam Ship the Metal, and we're releasing the metal analysis, and most of it was footage taken at IBM, when Vogel was with IBM, in his laboratory there.
Mm-hmm.
And most of it is microscopy work, combined with interview with Yowie. And it's fascinating because this first piece, Vogel remarks over and over, he cannot get over the purity of this material. Highly crystalline material in metal. Unheard of. Why would anybody want to do that?
And it was a great deal of lead and copper and brass and things that you wouldn't think would be in a flying machine, but all great conductors of electricity.
Yes.
Very fascinating stuff. And we have a lot more for it to go with you. We're just getting started on Open Mind tonight. With me is Lee Elders speaking to us from Alexandria, too. And Lee, I think they have the Beam Ship tape there, in fact.
I think they do, yes.
And I don't think they can keep it because everybody wants to see it.
I hope so.
I thought we might take just a moment here, if you don't mind. You sent me a fascinating piece of audio tape, and I want to share the sounds of the spacecraft. And Lee, I'd like for you to set the scene of what we're going to listen to here.
Okay, the setting is 1982. The sound analysis is one of our last priorities, Bill. We had already been, we'd spent about 3 or 4 years on the photos.
But this is radio.
Pardon me?
I said, but this is radio, so
right.
The sound analysis is important to us.
Yes, and we finally got around to it in 82. There had been some preliminary work done by Delatoso and others, but in 82, we took it into Los Angeles to a laboratory there, and we had 2 gentlemen really look at it close on their equipment. And coming up, you will probably hear my wife, Britt. She was present, and Wendell Stevens, and Steve Ambrose, and Niels Rognerud.
What lab was this?
This was Excalibur Studios in North Hollywood.
All right. So you're there, and it's this just sound tape you're working with that Billy Meier had recorded.
Yes.
And
this is variation. This is the second tape that he had made. The first tape was about 40 minutes. It was on Variation 2, The Craft, and this is on Variation 6.
It's interesting as this contact went along with Billy Meier that they kept coming up with new models of the spacecraft all the way through.
Well, you know, to an investigator, this has to blow you away, because every time we'd get this guy in one arena and think we had him surrounded, you know, like still photography, he would jump into another arena. He would take us there like sounds or metal.
Mm-hmm.
And it became a never-ending chase. So, anyway, it was a fascinating experience, and coming up with this tape.
All right. I want to share this moment with you as you're listening to the investigators themselves, as well as sound engineers, dealing with the perplexing things that they are seeing on their scopes as they listen to the sounds of the Variation 6 Pleiadian spacecraft.
You got it.
Scene 2, take 6.
It's very random. You see, there's there are maybe 20 predominant peaks.
We just get some screenshots.
There's the alarm.
Yeah.
Okay. I see basically five to 10 different frequencies registering on that. I mean, major, which is, I mean, if you count the major ones here, that's basically what you've got.
At this time, but we get more later when it goes into another mode, right?
Yeah, the mode is changing. We seem to have, at some point in time, a lot of frequencies, and then it simplifies down to it.
You have to put down on that.
Marker?
Action. You have to put down on that.
Marker?
Action.
We have two pieces of equipment. One measures the signal we listen to in the time domain, the top one here. And the bottom one is measuring the frequency components of the signal. And as we can see, it's changing, both on the top and bottom. The small instrument on the top here measures the main frequency component of the signal. At the moment it's around 1,000 cycles per second, which is right in the middle of your voice spectrum. Now there we had a very pure tone with very little added noise or other harmonics. But it's still it's an alignment of several tunes. It's not as though it just like there's an alignment of maybe 10 different tones.
There it is again. What's that?
Okay.
What does that mean?
Well, all of the spurious tones that you were getting before, all right, are tuning and aligning to the same frequency, or not exactly the same frequency, but near enough that it's not as though those different frequencies are falling out and one is coming through. They're aligning. You have it. See, it's. You understand what I'm?
Yeah.
It's not as though maybe before you had 10 different frequencies at random, and then all of a sudden 9 dropped out and you only had 1 left. What's happening is the 10 different frequencies are converging on one central frequency, which is I find very interesting because.
What is the system analyzer telling us right now? With all the erratic changes that we've got on the spectrum analyzer, what is it telling you?
Okay, let's pick a point here on the screen. Let's pick that point there. You see how the level of that point is changing, it's going up and down.
So you can see that there was a great deal of interest that was being demonstrated by the sound engineers as they heard these sounds that Billy Meier recorded of the later.
But he said there certainly aren't any synthesizers that have oscillators that are that many, you know, and can be randomly tuned to that many different type of frequencies. Another thing is they found out that One frequency that remained stable throughout the entire testing was, well, they compared it to the Schumann resonance factor.